Okay, assalamu alaikum my brothers and sisters. This is your brother Abdi Muhammad Noor who's going to take for you vectors. We'll start with the vector of form 2 by the way. Today we are going to do basically vector of form 2. Under this we are going to learn different or variety of concepts that will help you in form 3 for your information guys. So before we proceed to form 3 concept of vector, make sure you go through this video, you watch it thoroughly, then get the right concept, okay? Because in form 3, some of the concepts that are tested in form 2 will be tested in form 3 concept of vector. So I will start vector today, the last chapter of KLB. So what's a vector first? A vector is a quantity that has both magnitude and direction. Is a quantity that has both magnitude and direction, okay? And what's magnitude by the way is the distance, okay? Okay, the distance or the displacement, okay? Now, and we say the vector is a quantity that has both magnitude and direction, okay? Direction, okay? Look at this one. If I have a line like this, let's call this one A, B. So the distance AB is what we normally call magnitude by the way, okay? The distance AB is what we normally call magnitude. Remember, this is what? This is B. So now if I give it an arrow showing the direction, the arrow in a vector always shows the direction. So if this is A, let's say, if this is A, then or B, A or B. Now let's take A, vector A, okay? So we can say vector AB, written like this. Vector AB is equal to A index or vector A, okay? Vector A. Because the moment you're moving from A to B, remember you're moving along with the arrow. You're not opposing the arrow. So the vector you're going to get is what? This, the factor will be positive. So we're going to say vector AB is equal to this one, okay? A index, okay? So by the moment you're writing AB, you must show an arrow where the arrow is moving because you're moving from A to B. So if I want to get now vector BA, you see now, vector BA will be negative vector A. Why? Because I'm opposing the arrow. Can you say that? A vector is a quantity that has both magnitude and direction, okay? So this is negative vector A for your information. So this is one way of actually representing what? Vector, okay? So the distance AB is what the normally call is what we are talking about. We are saying magnitude, okay? Magnitude. And the direction is always shown by the arrow for your information, guys. Okay, after that, we are going to see what we normally call, after that, knowing the definition of what? Vector, we are going to see other concepts. Like, what if the vector has got only magnitude? Okay? A vector with magnitude only, like this one. Magnitude only, A, B. Then let's say this is vector B, okay? This vector is called what? Scalar factor, scalar vector. We call it scalar vector. A vector which has magnitude only, just like distance, okay? So what you normally call what? A scalar vector for your information, guys. Just understand the basic concept of this vector we're talking about, okay? Then we'll proceed to what we normally call equivalent vectors. This is what we are going to discuss about. Equivalent, from the word equal, vectors. Okay? So, when can we say two vectors are equivalent or they're equal? The word equivalent, I think you know it's equal. So when can we say two vectors are equivalent? Okay? That's what we're going to discuss about today. When can you tell us that these two vectors are equivalent, by the way? And this will help us ahead of us, okay? We are saying two or more vectors are equivalent if they have the same magnitude and what? Same direction. Don't forget that. Two or more vectors are equal or are equivalent if they have the same magnitude or what? Or direction. Just understand that. Okay? We are saying two vectors are equivalent. Two vectors are equivalent if they have the same magnitude or and direction, the same magnitude and direction. Understand that? So now let's say this is A, B. Then you have C, D. So if they have the same magnitude or what? And same direction, okay? Same magnitude and same direction. Okay. These two factors are what? These two vectors are equivalent because they are moving in the same direction, or they have the same direction and as well as same magnitude in terms of what? Length. Okay? Just understand. So these two factors are what? Are equivalent or equal. Okay? Just understand that. Vector AB is equal to what? Vector CD, because they have the same magnitude and direction. Just understand, guys. So we can say two or more vectors are equivalent if they have the same magnitude and direction. Simple. Just understand that. Okay? Okay, these two factors are equivalent for your information. Then without wasting time, remember we're going to learn the most essential part of vector form 2. Guys, the concept that will only help you because you cannot still tell about this one, but you have to learn the basic concept of vector form 2, which is very, very much examinable during normal exam or during KCSE, okay? Okay. Now let's go ahead. We are going to see what we normally call column factors, okay? Okay, column vectors, okay? How they work, okay? Factor can be represented as column vectors, okay? Column vectors, okay? Column vectors. Okay, vectors can be represented as a point or what? Or as a coordinate, as a column vector. Just like this. A vector written like this. A, B is what? It's a column vector, okay? This is a column vector. Just understand that. A, B, okay? A column vector. Where this A represents a value and B represents also another value. But when you're saying XY, okay? XY like this. This X coordinate and this Y coordinate of the point are given. Just understand that. So a vector represented like this is what we normally call what? Column vector, okay? We call it what? Column vector for your information, guys. Okay, now let's see how this one works. Sometimes you can be told to add. Okay? Let's see these ones. You are told simplify. Let's see example 1. You are told simplify. You are told simplify. Okay? We have we have 2, 1 in bracket plus 1 negative 3. So if I want to simplify this one, it's a matter of what? Adding. So what will I do? I will say solution. So I will have 2, 1 plus 1 negative 3. So this can be written as, open a bracket, 2 plus 1, 2 plus 1. Under that, 1 plus negative 3. So this can be written as, add these two, 3, 1 minus, remember, we have 1 plus negative 3. That will give us what? 1 minus 3, which is negative 2. Okay? And that is the final answer for your information, guys. That is the final answer for your information, guys. Okay, let's also see this one. Let me add for you another one. B, we have B as 4 5 plus, open the bracket, we have another one as, sorry, here we have minus 1 minus 2 in the bracket. So if you want to solve this one, what are you going to do then? You are going to say solution part, the same thing we have been doing right now. 4 5 plus, sorry, minus -1 -2 is equal to 4 minus -1, 5 minus -1. Remember, we have minus here in between the two, and in the bracket we have minus. So this will give us what? 4 plus 1, 5 plus 1. So this will give us 5 6 as the final answer for your information. That's how you're going to solve anything concerning about this kind of vector. So let me see also example 2, because sometimes, let's see example 2 as this one. Still, we remember we are still within the column a vector. Given that you are told, given that A is equal to, look here, 2 -4. A is equal to 2 -4, and B is equal to -3 3. Okay, then you're told evaluate, you're told 2A plus 3B. Question A, 2A plus 3B. Okay, then question B, we have another question there, which is half A minus a third B, minus a third B. So if I want to solve this one, remember I have 2A plus 3B. So how will I solve? I'll say 2 into A value, which is -3 3, -3 3, close the bracket, plus 3, open the bracket, B. B is what? -3 3. Sorry, our A is what? Sorry, our A is 2 -4. 2 -4. So what is -3 and 3 is what? Is B. So A is already what? 2 -4. So you're going to say 2 times the value of A. In this situation, you're going to say this times this, 4 minus 8, because this times this is 4, this times this is what? -8. Plus, open the bracket, this times this, -9. Okay, this times this, 9. Okay, this will give us what? This will give us is equal to 4 plus -9 minus 8 plus 9. Finally, you're going to get what? -5 1. Okay, and that is the final answer for your information. So this one is yours. Do this one as your assignment. Okay, that's Mampia what? Mampia scale factor. Oh, sorry, Mampia column factor. Okay, Mampia column factor. Then we will go ahead and see the magnitude of what? The magnitude of a vector. Okay, how to get magnitude. Okay, that's what they're going to discuss. Let us see how we are going to get what? Magnitude of a vector. Okay, let's see this one. We are going to talk about this one. Magnitude vector. Okay, let's say we are talking about vector B. Okay, so the magnitude of vector B is written like this, equal to x squared plus y squared. Okay, into root. This is how we are going to get the magnitude of vector B, that is x squared plus y squared. That's how you're going to get for your information, guys. So sometimes you can be given, let's see example 1. Example 1. You are told given the vector, AB is equal to -2, 4, comma, you are told calculate, you are told calculate the length of AB, the length of AB correct to 2 decimal places. 2 decimal places, okay? So this is what we're going to do now. Remember, we want to get what? Solution. We have what? Remember, this represents x coordinate and this y coordinate, okay? So we want to get vector AB, okay? Sorry, we want to get the magnitude of AB. So we are going to say the root of x squared plus y squared, okay? This is what they're going to say. In this situation, magnitude AB therefore is equal to the root of -2 squared plus 4 squared, okay? This will give us what? The root of 4 plus 16, that is 20. Just understand that. So that will give us the root of 4 plus 20. So the magnitude of AB therefore will be, sorry, this is 16, yeah? Don't forget this 16. So it will be how much? 20. The root of what? The root of 20. So this will give us how much? We are going to use our calculator. Okay? We are going to use our calculator. Root 20 is what? 4.7. But you are told what? Correct to 2 decimal places. It's 4.47. Okay? This will be 4.47. Okay? To 2 decimal places. That's how you're going to get the magnitude of vector AB. Okay? That's how you're going to get the magnitude of vector AB, guys. Let's go ahead and see this one again. Okay? Let's go ahead and see this one. We have here, let's see another one, because it will help you guys. I'll give you more examples so you understand better. Okay? Look at this one. This will be example 2 here. Example 2. Okay? Let's see this one. You're told given A into 3, 5, comma, no, and B 7, 11, okay? Find vector AB, find vector AB and calculate and calculate and calculate the magnitude of what? The magnitude of AB and calculate its length. And calculate its length AB. Correct 3 significant figures. Correct to 3 significant figures, okay? We'll stop. Okay, we will not stress ourselves. This time we have vector in point form, okay? We will write them in what? In what you normally call column vector. Remember we are going to map A onto what? Onto B. So let's get change in x coordinate, okay? Change in x coordinate. That's what? Remember this x1, this is x2. So that's x2 minus what? x1, which is 7 minus what? 3, which will give us 4. Get the change in x, okay? Because we want to map A onto B. Then change in y coordinate. Change in y coordinate is equal to y2 minus y1. Remember, this is y1 in the first coordinate, in the first point here. This is y2, 11, okay? So that's 11 less what? 11 less 5. So that will also give us 6. So our column vector now will be, that's xy, okay? So we are going to get the magnitude of what? AB is equal to x squared plus y squared into, which is 4 squared plus 6 squared into root, okay? So that will give us how much? 36 plus 16. Root answer. So that will be 7.21 to 3 significant figures here. 7.21. So that's how you're going to calculate, guys, the magnitude of a given vector. Just understand, it's very easy. Okay? That is how you're going to calculate the magnitude of a given vector. Okay? Fair information. Okay, in our last point, we're going to discuss about what you normally call the midpoint. Okay? Midpoint of a vector. Then that is as far as form 2 concept is concerned. Okay, pronouns, the place where students have got pronouns with vector is form 3. However, form 3 vector is also very, very easy, by the way. I've tried my best to exhaust my energy as far as your demand is concerned when you reach vector form 3, of which you're going to discuss in our next class. Because the moment you are done with vector form 2, we have to proceed to vector form 3. Guys, we will be doing KCSE this year. Make sure you watch the upcoming videos and this video concerning about what vectors, okay? It will help you, of course. It will help you, it's going to help you. Okay, then we are going to talk about this one, which is the last part, okay? We are going to talk about midpoints, okay? The midpoint of a vector is what we want to talk about. Midpoint of a vector. Okay, let's go. So this time we are going to talk about what? The midpoint of a vector. Midpoint of a vector. Midpoint of a vector. Okay. So midpoint of any vector is equal to x1 plus x2 divided by 2 comma y1 plus y2 divided by 2. Just understand that. Divided by 2. This is also, remember, this is 2, yeah? So this is how we're going to get the midpoint of a vector for your information, okay? It's very, very examinable, okay? So you're told, let's see the first example. Let's see our example 1. In our example 1, you're told, given the points, a negative 2, 5, comma, no, we have and b 6, negative 3, b 6, negative 3. Find the coordinates of the midpoint of AP. Find the coordinates Find the coordinates of the midpoint. Of the midpoint of AB. Full stop. This is very easy, yeah? Come to the solution. We have A as what? -2, 5. We have also B as what? 6, -3. So this x1, y1. Don't forget this x1. x2, y2. So we know that midpoint is equal to x1 plus x2 divided by 2, then y1 plus y2 divided by 2. Okay? Come to this point. Our x1 is what? -2 plus x2, which is 6 divided by 2, comma y1 -3. Look here. y1 -3. Okay? y1 is what? Our y1 is what? Our y1 is 5. Okay? Our y1 is 5. Okay? 5 plus -3 divided by 2. So this will give me 4 divided by 2, comma. This one, 2 over 2. This will give me what? 2, 1. Okay? 2, 1. So that's the midpoint. Okay? 2, 1. Final answer. You're going to say what? x1 plus x2 divided by 2. Okay? Then, comma, y1 plus y2 divided by 2. Very easy. So that's how we are going to get what? The midpoint of any vector. Okay? The midpoint of a vector is gotten as x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2 for your information. Okay? Okay, otherwise I think that is the little concept of form to concept, form to vector, the little concept concerned about what? Form to vector. Make sure you go through this thing, friends. Okay? In our next class, we're going to discuss about vector of form tree, which seems to be very crucial by the way, though it's very easy. It's a, but I think I don't know why people are making what? Vector form tree very hard. It's very cheap. It's only the last part where you'll have to solve the equations simultaneously. And remember, it's basically concerning about that diagrams, the likes of parallelogram, rectangle, triangle. You see now. Then we will solve trapezium. Okay? I'll solve for you equation of 10 marks of form tree. Don't worry about that. Again, in form tree, we are going to test what we normally call parallelity and coronarity. Okay? We're going to test that. Relation theorem. We are going to test all of them. Okay? Okay? Otherwise, I wish you the best. Have a nice day. Make sure you subscribe and share this video with your family members and friends and those who are stranded at home level due to COVID-19. Make sure you do that, please.